Law of cosines is another handy formula. Again, it is on your formula chart right here. And here's law of sines, and here is a reminder of how to set up a triangle. And you can use the law of cosines to solve triangles that are not right triangles. You can use law of cosines when law of sines does not work. You can use law of cosines when you have three sides that are given, or you have an angle and the two sides next to that angle. I'm going to do an example of a three-side given triangle because there is a tip to avoid having to do or deal with the ambiguous case. You'll notice that once you use law of cosines one time, you'll have enough information if you want to go back and use law of sines to solve the rest of the triangle. Be careful though, because with law of sines comes that ambiguous case issue. Here's a tip. When you are drawing your triangle, again, it doesn't matter how you label the angles or what order you label the angles in. It does, however, matter that the sides are across from the angles correctly. Let's plug in what we know. We know that our side B is 8. We know that side A is 6, and we know that side C is 12. If you find the angle across from the largest side, you will not have issues with the ambiguous case. That is my recommendation. So let's start, and we're going to find angle C first. So let's use this formula right here for angle C. Notice there's two sets of formulas on this formula chart. These are for side lengths and these are for angles. It's nice because they've already been solved for you. So let's use cosine C. So we're going to use cosine C equals, and then we're going to do a squared plus b squared minus c squared over 2 times a times b. And now let's plug in what we know. All right, so cosine of C equals a squared, so 6 squared, plus b squared, or 8 squared, minus c squared. Ooh, I wrote this wrong, sorry. C equals 12, I apologize, minus 12 squared over 2 times 6 times 8. Now when you plug this in your calculator, you're going to use the inverse of cosine to find angle C. Anytime we're looking for angles, we have to use the inverse of that trig function. So here's how it's going to look. Cosine inverse of. Now when you plug this in your calculator, I recommend doing it all at one time. You just need to use parentheses correctly. When you hit inverse cosine, one parenthesis is going to open. You want to put your numerator in parentheses and close your numerator. Then you want to divide by your denominator in parentheses. 2 times 6 times 8. Close your denominator, close your inverse. And if you do it like that, you'll get it right every time in your calculator. So let's go to our calculator and plug this in. So we have second cosine, parentheses for my numerator, 6 squared plus 8 squared minus 12 squared, close the numerator, divide by, open the denominator. 2 times 6 times 8, close the denominator, close the inverse. And you get that angle C is 117.3 degrees. 117.3 degrees. Now remember how I said we won't deal with the ambiguous case? I like to now go to law of sines. It's easier, less entry into the calculator. So what I'm going to do is I have an obtuse angle, so I know I'm not going to get ambiguous case. I'm going to set up the sine of the angle that I just got over the side opposite equals the sine, and I can choose either one now. Let's go with A, over little a, which is 6. We're going to cross multiply and divide. So you find out, ooh, I put C instead of 12. I apologize. All right, so we're going to cross multiply and divide. We find that 12 times sine of A equals 6 times sine of 117.3 degrees. Divide both sides by 12. That will isolate the sine of A. And we can go to our calculator. We need to use inverse trig functions again. So in our calculator, the way we're going to find A is we're going to take the inverse of sine, and then we're going to put all of this in. 6 sine of 117.3 divided by 12. All right, let's go put that in. Second sine of 6 sine 117.3. Close that sign, then divide by 12 and close your inverse. And you get 26.4 degrees. So A equals 26.4 degrees. Now we have angle C, we have angle A. It's real easy to find angle B. We're just going to find what we need to make up 180 degrees. A whole triangle is always 180 degrees. Let's subtract the angles that we know. We know that angle C is 117.3 degrees and angle A is 26.4 degrees. So angle B is 180 minus 117.3 minus 26.4. or 36.3 degrees. 36.3 degrees. That is law of cosines.